The AVR XMEGA devices from Atmel are an 8/16-bit microcontroller family designed for high system performance and low power consumption. Now, XMEGA microcontrollers also feature a full-speed USB device module. And everybody loves USB. It's fast and easy to use. But developing a USB application is usually not just plug and play. There's plenty of complex software involved and real-time constraints that eat up your microcontroller resources. Also, an accurate clock source must be present, and this adds to your bill of material. But with XMEGA, we have made sure that it's very easy for you to design with USB and add USB connectivity to your applications. You will get a high USB data rate with low CPU load, and we also let you save costs by eliminating the accurate crystal typically required for full-speed USB. So with XMEGA, no external components are required to get full-speed USB running. Let's take a closer look at the USB performance benefits of the AVR XMEGA on the whiteboard. We're going to use bulk transfer as an example. While full-speed USB is specified to 12 megabits per second, max data throughput for bulk is 9.7 megabits per second, in theory. The actual data throughput depends on your microcontroller. It must be able to work close to the maximum speed, process all the data packets, and still have time left for other application tasks. First, let's look at the speed-enhancing ping-pong function of the XMEGA USB. Without ping-pong, in what we call normal mode, the receiving MCU may have to issue a NAC packet to the bus if it didn't manage to process the previous data packet. This takes a bus time, the data rate goes down, and the MCU that wants to send more data has to wait. With ping-pong, two data packets are buffered simultaneously. Since the buffering is handled by hardware, no NAC handshake is necessary in between those two data packets. This gives higher data rates on the bus and more spare time for the sending MCU. You get a slightly higher CPU load, but more continuous time between NACs, meaning better predictability and relaxed real-time constraints. This timeline is a worst-case scenario. In real life, you could potentially eliminate all the NACs, depending on the data processing requirements. The numbers in this table are from real XMEGA micros running real software and shows that we increased our effective data rate by almost 60%. But for bulk transfers, ping-pong mode is best for data packet sizes up to 64 bytes. And this is why multi-packet mode was invented by Atmel with mass storage and CDC applications in mind. Here's the thing. In USB full-speed mode, bulk endpoints are limited to 64 bytes, while the USB mass storage protocol requires multiples of 512 bytes. So during data transfers, data has to be split and merged several times. Without multi-packet, packet splitting or merging must be done in firmware, tying up the CPU and consequently also slowing down the USB. With multi-packet, hardware automatically splits or merges the data with respect to endpoint size, greatly reducing CPU load and firmware overhead. Of course, the data rate increases. Looking at our table again, the data rate increase is similar to ping-pong, but the CPU load is much lower. Now, look what happens when we combine multi-packet and ping-pong. So, if you're concerned about the increased CPU use of ping-pong mode, you can use XMEGA and get both a high USB data rate and low CPU usage. Let's try to get an overview of when to use what. Here we have data packet size on the x-axis and USB data rate on the y-axis. Ping-pong gives very high data rates, but needs CPU time, and for bulk transfers, it's only relevant for packets up to 64 bytes. Multi-packet gives both high data rates and very low CPU load, but is most efficient for packet sizes from 512 bytes or so, and gives slightly higher RAM usage. Combining multi-packet and ping-pong gives both high data rates and low CPU load, also for data packets down to 64 bytes with medium RAM usage. You can spend the extra CPU time for other tasks, or go to sleep, or lower the CPU frequency to save power. This is a winning combination only possible with AVR XMEGA. But you really don't have to worry about how all this works. It just does. Inside AVR Studio 5 and the AVR Software Framework, you'll find complete, ready-to-use XMEGA drivers for all the most common USB device classes, giving you all the performance benefits you just saw. To save you more time during development, we have done USB certification of the XMEGA USB devices and the explained evaluation kits using these drivers. With no need for an external crystal, this should be a no-brainer for your next application with USB. AVR XMEGA devices with USB are available now and fully supported in AVR Studio 5. Thanks for watching.